Okay. Yeah, we can get started. So thank you for all the participants. I think not all the participants are here with us, but I do see a couple. So later, so then I'll first explain what we can do with the results and how to interpret them and how to take this work forward. And then I would ask the participants to say a couple of words about their approach. If you'd like to share code, you can. And then it'll be an open discussion on your feedback, on people's questions and discussion points, etc. So let me share also some visual. Let's get this going. Okay, so I hope you can see the presentation. And it's the beginning of it is the same as we have talked about earlier. So let me just skip through here. We have been solving modern slavery. So if there is anybody in here who hasn't participated in our last two sessions, we're here to solve modern slavery using corporate modern slavery statements. So the goal is to mine what is, understand what's inside the modern slavery statements, how companies are treating modern slavery in their supply chains, and and then more specifically, we've been looking at if the company provides any training, any modern slavery related training to its employees, and if they do, then they should be talking about this in their statement. And we have then published a Kaggle dataset based on Wikirate collected data, and then asked everyone to join in the competition and compete for the prizes. So let's take a look at what's happening. Let's look straight into the leaderboard. I presume many of you who have competed have already taken a look. So no clue what I'm doing has won this competition. It would be great to know who is this. Are you with us during the call today?
Congrats, Sahil.
Hi, Sahil. And then second place, we got Sam. And very interestingly, Sam then scored the 6th place in the public board, but then in the private got a much higher score. And then we got White Noise and Fungi. Are you guys with us also today?
Hello, I'm third one.
Lovely, thanks. What's your name?
Arto.
Arto, perfect. Yes, so that's our leaderboards. Now, in order to then confirm the prizes as promised, it will be then important that we can see your code that you have used to train your model and to score the submission. So please either submit it through the notebooks section on the competition, or submit it through our GitHub, so you can make a pull request. to the Modern Slavery Statements Research GitHub. Or you can just send it to me personally, and then I'll include it into the repository. So we would ask then the 3 winners to do that. So Sam excluded himself from the prizes, so that applies then these 4 people here. Okay, so that's the key condition, that in order to win, then it would be important that you would share your results with us. Now, what next? This was then a very great start, and all the participants, if you then send me your GitHub, you can then become a contributor at our open source repository. And then you can also include your code in here yourself, and then add future updates as well. Then all contributors who are providing us with sustained contributions over the next few months, say 4 to 6 months, providing some significant contributions, may become part of the Future Society Affiliates Network. That is a renowned network of individuals who are all contributing to the advancement of AI and AI for good initiatives. And so this, you can then become part of it and further contribute to the goodness of AI in the world. And then some suggestions on how to make this work that you have made today, by today, useful. So what is important is that you have an algorithm, and in order to really use your algorithm in production, so to say, for field work, we really need to understand your errors. So false positives, false negatives. So what I would suggest is to make note of what I'm sharing here, and then bit by bit start sharing your analysis in our public repository, that we can then that can then become a part of the larger project. So what is important is to understand the false positives and false negatives. We need to understand your success based on thresholded metrics. So log loss is a non-threshold metric, which is good for understanding the confidence of different models. But then when we really want to start benchmarking new modern slavery statements based on your algorithm, then it would be important to understand where are those more successful or less successful. So using metrics such as AUC, precision recall, etc. Also, it's important to explain your predictions. So what features are the most instrumental in determining the prediction, and how do those predictions come about? So to really get to the crux of it, and then also the stakeholders, such as academics, researchers, and NGO workers, they can really know how this tool must be interpreted. And then deploying the model in an MVP format. So our project at the Future Society makes use of AWS. So then you can be onboarded to our AWS ecosystem, and then make a very simple API to which we could then pull the results of future documents through the API. And then it would be useful to create a simple visual interface to your model. So for example, in Python, there's Streamlit that allows creating very simple and straightforward interfaces that has really been taking off in the ecosystem as a simple dashboarding tool. So if you would then like to take your work further, then these are the suggested steps to really make your model useful. Of course, improving the model itself is also necessary, and then you can make those improvements, add them to the open source repository, and then through your and that's how you can make your contributions useful to the projects in general. Is there any brief questions about what I just shared about how to take this work further? Okay. In that case, I would then ask the participants, so starting with whoever wants to be the first, or we can go by the leaderboard to share their work and lessons learned through this modeling process. So it would be interesting to hear your methods that you used, as well as some some interesting aspects you discovered about the data, or some questions you have about the data, etc. So let's see. Is there anyone who would like to go, who would like to start this?
I would like to go first. Can you hear me all right?
Yes. You're Rodney, right?
I'm Rodney, yes. And since I wasn't able to get up there since I was at the bottom, I would like to start because maybe the rest of the submissions will give me more clarity as to what I could have done better. So it was my first NLP problem, and so basically I started with I wasn't sure how to really structure the solution, but what I tried was a bag of words approach, and then TF-IDF, but only with the words I found in the text. Later on, and reading a bit, a good approach, or an approach that I thought would be useful, was to use bigrams and trigrams in order to extract more features on the text. But sadly, what I would have liked to do, but I wasn't able to actually extract those features, was to try to identify words or type of words, or I mean, doing some POS tagging about what parts of speech indicated that the statement was truthful or not. One analysis I tried to do is if the company said that provided training, but the expert or the person tagging the article identified that it didn't. What I tried to do was find out if any of the words gave that up, or if they gave away the fact that the statement wasn't truthful. That didn't prosper. And as for the algorithm, I tried a regression forest only as a baseline. I was thinking about using a neural network in order to improve on that. But when I got there, I struggled with the structure the network should have, because, well, I hadn't done it before. So I wasn't able to improve much on the random forest model. With my neural network, I wasn't sure how many layers or number of neurons to use. And I wasn't able to dedicate as much time as I would have. Still, it was a very nice experience. And I would if I had to do it again, I wouldn't jump so quickly onto the neural network and try to improve my feature engineering before jumping on a more complex algorithm. But it was fun all around.
Thank you so much for sharing it. These are very interesting thoughts indeed. So basically, starting off with the basics and then moving further to neural nets. So I wonder if anyone else also used similar approaches like TF, IDF, and etc. Did you get some good results with that?
That's basically what I did. I used a pretty standard pipeline. I did TF, IDF. I also tried the count vectorizer, but I didn't get, they were pretty much the same. I used random forest as the classifier, and I did a grid search around a bunch of the parameters like max features, etc., for the vectorizer and the number of estimators and stuff like that for random forest. And I think the one that ended up performing best on the private leaderboard was probably the first or second submission with that basic pipeline. I was like Rodney, I had high aspirations of doing a lot of feature engineering, and I ultimately wanted to, or aspired to get to maybe trying to do some kind of embedding space and classifying based on that, but I didn't quite get to it. And a bunch of the things that I tried to do beyond that basic approach made my public leaderboard score decrease, which was discouraging. So I didn't follow those directions.
Very interesting indeed. So basically what we're learning then is that the basic approaches took everyone quite far. I wonder, is there then anyone who used some pre-trained models?
Can you guys hear me now?
Yes. Hi, Sahil.
Oh, okay. Hi. So yeah, my approach was also not too different from Rodney, and I thought a bit of Sam's approach as well. Basically, mine was surprisingly the winning solution, because I'm fairly new to NLP and working with text, so I was literally going through tutorials, trying to understand how to go through it and applying new things as I learned. I basically tried my final model, the one that scored relatively was using the TF-ID vectorizer and the snowball stemmer as a for the stemming, and reward tokenize as well, and bit of pre-processing with the text data as well, which was basically I tried to use lowercase, which was a bit tricky because there were quite a lot of proper nouns and company names and acronyms inside, but I still went with it. And there were also, I also removed alphanumeric, non-alphanumeric characters and stop words as well. And I used a basic logistic regression model and trained over it using stratified cross-validation approach. Not that complicated of an approach, but after that's when I started to realize that I need to try some more complicated approaches, which I was not quite familiar with. So I went with word embeddings, tried to use the fast text embeddings. I think that's Facebook's Facebook research's word embeddings. I tried to incorporate that. Didn't help much at all. I don't think I submitted that one. I just tried it and tried to see what the loss, and I was also tracking the accuracy, even though it wasn't that helpful, but didn't really improve that much. Then I tried to use LSTMs, didn't help at all. I also asked a question related to that in the Slack, which was like my loss values and everything was jumping around a lot. So I just abandoned the idea. Then I went back and started going through the data properly through the text, tried to try to get more of an idea. It became pretty clear after that that the only thing that could actually improve it further would be actually cleaning the text as much as possible. Like going through it, I've just for, I think, the word trafficking, I think I found 4 different ways that it was spelled out or misspelled at least. And there were multiple occurrences of such. And there were words from, I think, different languages as well. So I tried to clean it up, but I reached a point where I was struggling to clean up escape characters, and I got so frustrated I stopped after that. So I didn't really try much after that, but I think in the end, the final approach would have been to clean the data as much as possible. I was actually I created a dictionary to actually manually map the misspelled words or the words which are different but were occurring too frequently, and tried to modify them so that they could be used for word embeddings in a better way. But I never got around because there were some escape characters in it which I couldn't figure out in time, and I got honestly frustrated with trying to figure that out. I spent like 3 hours on one escape character and wasn't for some reason not cleaning up in pandas, so I just gave up at that point. But yes, the basic approach was quite similar to what Sam and Rodney also pointed out to. But the most helpful, actually, the push was because I cleaned up the data just a little bit, which actually helped. So my assumption is cleaning the data much more would be required to actually improve the model. Something interesting that I actually wanted to ask everyone, because I was trying to understand how to go about actually looking such a large corpus of text, because I hadn't worked with it and tried to see. So I saw some approaches online, which on past Kaggle competitions, which were basically trying to see the word frequency as, using bigrams or trigrams. And I saw that for both classes, a lot of words were actually common in both of them. So a direct approach which would adapt to, learning the context might not be helpful, which was a bit surprising to me, because I thought, groups of words might give an idea of which approach might work better. But I saw that a bunch of words or groups of them or bigrams and trigrams were actually common to both classes. And that was surprising to me, unless my code was wrong. So that's a different thing. But if anyone actually tried, going through the route of visualizing the data and trying to see patterns or anything like that, I'd love to hear about it, because I honestly don't think anything else might have worked that well, because unless you were cleaning the data heavily. But yeah, that was my approach.
Yeah, that's very interesting. So thank you for sharing. Yeah, so it seems that basically there wasn't such a huge methods difference between, let's say, the first place and the last place. And it was more that who was able to then clean the corpus more or more relevantly.
Well, if I may, my approach was very different to what other participants did. So I'll try to share my screen to walk
Go ahead.
through this. So, okay, can you see it?
Yep.
So this is a notebook. So what I did here was I used a pipeline from Hugging Face. I used pre-trained model. This BART is one of the latest transformer models made by Facebook, I guess. So what I did, I have this is like a model trained on MNLI data set. So it is supposed to answer a question like, is some statement a contradiction to the premise, or it's an entitlement? So I made some like here this candidate labels, like training is provided, training is developed, and no training specified. So then I walked through this data set. I actually used before that I pre-processed, like I extracted the sentences which are supposed to be most related to training, and walked through these sentences and generated like probabilities for each of these statements being true. Well, one problem with this approach, it's kind of difficult for model to say that like nobody will state that they do not provide any training. So if training is not provided, there is nothing about training in that statement probably. So this statement is either entailment or neutral, and very rarely it contradicts. So one thing which one can do to improve on what I did, to construct this statements to be more polarized in relation to what we want to know about this text. Actually, that's how I generated some features, and to be honest, I just did it like a couple of hours before the deadline. So I just throw those features into logistic regression and made predictions, which is also not the best way. That's how it worked. And also, actually, I tried a lot of fancy models to do stuff with this data, and that was fun. I did a lot of, I tried a lot of approaches which I never tried before. So like a T5 model generated pretty good answers if you ask it like if training is provided, but I never used those in my predictions because like I spent most of the time playing with this stuff, but not actually trying to produce good results. So yeah, but actually I also did some fast TF-IDF approach, and it was like pretty similar score it had to this stuff. But actually I saw a paper which like they trained IMDb dataset on IMDb dataset with only 20 supervised examples, labeled examples. So I was really curious to try that consistency training, it's called, but actually it like should take some time, and you need a lot of unlabeled data from this domain to make it work. But that's what I'm going to try when I have time for this. It's really interesting, I think. So that's it.
That's very interesting. So if I then recap, so basically you set up a zero-shot pipeline, and then you set up a variety of different candidate label sets, and then using the zero-shot pipeline, you calculated the probability for those candidate labels. Is that correct?
Yeah. Basically, that's what I did. Also, I did this sentence extraction, which I'm not sure it was really useful. What I thought that like if from a human perspective, if you give this statements to a human with only binary labels, and if I read those labels, that would be really difficult to figure out what exactly those labels are about. So I decided to like extract more training related part of statements to make it easier for model. But I think I extracted like one sentence is a little too short. So it's probably another way to improve this approach, to extract like larger spans, like a paragraph which contains relevant information would be like 5 or 3 sentences around that. I think would be good. So.
Mm-hmm. That's yeah, that's super cool. So, and I because here it doesn't seem that you did too much like data cleaning. Eh? Like you almost like ingested the whole document in with some stemming. Was that?
Well, actually, I did data cleaning with another pre-trained models. So I like throw all those statements. I truncated, like if it was too long, I just truncated the trailing part. And I used this BART model, which takes like 1024 tokens to summarize those texts into something around 200, 400 tokens. And then I used different models to like query those parts for some data. But actually, I have this input data, like this commented section is for adding like back translated sentences, but I never had time to really use those. And I think I'll play some more with all this data later. It might be fun.
And was that that wasn't very, you didn't need a GPU to do that, right? Like it was just a regular CPU run on your local machine, or?
Well, actually it requires a GPU. For example, this BART model is quite slow on CPU, but for example, I tried training distilled BART. It's distilled version of BART model, and it trains quite fast on CPU, but obviously it was overfitting very badly. But I think with more unlabeled data, one can make use of those data to train that model. So.
Yeah, that's great. Thank you very much for sharing. Let's see. Is there anyone else who would like to share their results or lessons learned?
So I missed the deadline, but I was working on, and actually it's still running, a slightly different approach. So I took the text and I generated embeddings for each token using Roberta. And then I trained a convolutional neural network to go over those token embeddings and try and generate a prediction that way. So my thought was that any statement is not going to be throughout the entire document. It's going to be somewhere fairly local. So I thought it would be a good application for a convolutional neural net. Unfortunately, what I found is I got into hyperparameter tuning and has struggled a bit. Ran out of time tuning hyperparameters, and my best performing model on my local validation set was the one that just predicted the class distribution, the same percentage probability for each for each document. So hopefully I'm going to keep running it and see if I get better results as I continue tuning hyperparameters. But that was my thought. Welcome to any input on that. Oh, Edgar, you're muted.
Yeah, sure. Yeah, that's very interesting, because I was thinking that the CNN approaches should be quite much more lightweight, or like especially deployment wise, so not requiring like hardcore hardware or anything like that. So it would be interesting to know how the accuracy would play out with that. But in any case, yeah, I think you should definitely take your solution to the finish line and score some documents. It'd be cool to see that.
Yeah, I'll see how it does.
Sweet. Is there anyone else? I think, okay, we heard Sahil, we heard Rodney, we heard Arto, we heard Sam. Okay, so it looks like all the participants who are here today have already shared their lessons. We also have here Karina, who has been working with us in the Future Society and preparing a lot of this data. Hi, Karina. Is there something that was sparking your interest, or do you have any questions to anybody about this?
Hi guys, thank you for your participation. It was nice to hear your feedback, very interesting. It is very interesting that you used almost all of the solutions that we were thinking about, and probably you saved us some time doing all of this. That was great. About the last solution that we heard, I had a question, maybe I missed what you said, but did you say that you did convolutional neural network on the character level or on the word level?
So I did it on the token level. I tokenized all the documents using the Roberta tokenizer.
Okay.
Yeah.
Okay, yeah, that's cool. Thank you very much. That was useful. But so far, I don't have any specific questions. It was nice to hear your experience.
Yeah, exactly. Does anybody else have any questions to anyone else, or about the further collaboration options here? Dead air. Dead air is a sin. So what we'll then do, I would then encourage all the participants to post your email address alongside your Kaggle username, so that we can put the two together. So please post in the Slack channel your name, your Kaggle username, and your email. If you don't want to post in the channel, please send it to me privately. And then we'll give a couple of days for the first ones to send in their code. And when we've done that, then we can share out the prizes accordingly. Yeah, I encourage everyone to check out our open source repository. So absolutely anyone can get access to modern slavery statements data and start developing their own models and contribute to the research. There's lots of interesting patterns to discover and useful solutions to be created.
Edgar, I do have a question for you and or Karina about this in terms of the future collaboration opportunities. Are there other approaches that you had in mind or think are interesting that you haven't tried and no one mentioned that may be kind of high priority areas for exploration if folks want to continue?
Mm-hmm. So in-house, we have not actually built any models yet. What we are currently focused on is to improve the quality of the data. So because these are, these are PDF and HTML extractions. So we've been improving the pipeline to make that, to make the literal text extraction from those files better. And then additional to that, to improve the size of the labeled data, data corpus. So we are then currently collecting the domain experts' experience on this, on working with modern slavery statements. And we're in the process of encoding those into Snorkel labeling functions. So to use the weak supervision paradigm in creating more automated labeled data. So to then train the let's say the final algorithms on much larger corpuses, and then it's and seemingly we then started with the same training label. So then through this competition, we've kind of seen what's the amount of pattern that can be found based on this small corpus. And then as soon as we have the weak supervised labels available, then it would be very interesting to run your approaches on the larger labeled corpus to see the results there. All in all, I'm thinking that one thing that hasn't been used in this competition by anyone was some type of long document embeddings, such as the long former, or there were a few more which I can't remember now. So it would be interesting to see, like Big Bird, it would be very interesting to see how those long document processors would also work here.
I had another question. Most of the collaboration you mentioned is regarding to the project and the models that you are developing, or at least that's the part of the project that you put the competition to. But I was wondering if there are any other areas of collaboration that one could get into, such as, I don't know, as we have seen with Sahil's approach, apparently cleaning the data was the thing that made a difference. And you just mentioned that you are streamlining the pipeline to get the statements cleaner and clean that data. Are you open to collaborations in that regard? I mean, is it that on the project as well, or is not something you are open sourcing to the community?
Yeah, definitely. So for example, the pipeline, we haven't open sourced that so far. However, we're definitely welcoming contributors. So if there's anyone who you yourself, for example, or anyone else who has some ideas on how to either create more data, create better data, create a better corpus, create some tooling around like the analysis, then actually all of this is welcomed. And it goes without saying that any open source contribution shall remain open source. And then we will share our resources to you, and then you can then also use that to build your own portfolio and then openly contribute to the research. We are also writing papers and submitting papers to conferences. So if anyone is interested in specific research on an academic level, then there's a possibility that too. And yeah, so the collaboration options are very open.
All right, thanks.
Another question for you, Edgar. Do you have an internal kind of benchmark for utility of models in this area? I just looking at the kind of the log loss that we were seeing on the leaderboard. It wasn't terribly better than just predicting the class distribution, and so where does it need to be in order for it to be useful for the ultimate goal?
Yeah, that's a great question. So there is no set benchmark. However, yeah, it's true that for this work to become really useful on the field, the level of accuracy has to majorly improve. So that's an open area of research. And some more different types of, so that's part of the reason why we're working on improving the data, because I think this competition also showed that we need more data and we need better quality data. We need to eliminate noise from the data. It was great to kind of see the witness of that through this hackathon. So those are parts, and then also what I think needs to happen is to find great methods to remove let's say noisy texts. So one aspect is noise in the labels. So that's something we're working on now. But then also to, before even like feed any text to the model, to remove noisy text and to have some great methods to identify relevant parts of the text. So I think that's, if those two steps are taken, I think then we would expect to see the model accuracy go up. Yeah, in terms of the benchmark, there isn't set one. Because so far the job is purely done by human reviewers. So any confident result will be an improvement here, basically.
Yeah, it seems like even if you're not able to fully automate it, maybe some kind of model that highlights the relevant sentences for the human auditor so that they can more quickly get through these could be a useful way to go.
Yeah, absolutely. Yeah, that's something we're looking into.
Cool. No, really appreciate you putting this competition together. It was certainly fun from my perspective, and enjoyed seeing all the work that folks put into doing it and the different approaches.
Thank you for participation, and thank you, Sam, for throwing together a TWiML Fest, which is a great platform to throw awesome events like this and to bring together lots of very interesting people in machine learning and NLP space. So I think bigger thank you goes to you. Okay. Yeah, so Rodney was asking if we could post the GitHub repo in Slack. Yes, I will do that. And if anyone has any more questions, write to us in Slack, write to us an email. There's, I think, one more day of TWiML Fest left, or maybe even to the end of the week. So take part of all the events that are still there. Highly recommended, as well as join the different TWiML channels for different study groups. Social learning is really cool. Okay, and here I would then close the session. Thank you, everyone.
Awesome. Thanks, everyone. Thanks, Edgar.
Thanks.
Thank you.
Thank you. Bye-bye.